goes. All right, so this is going to be called solving rate conversion problems. And these tend to throw people for a loop. Okay, so the classic one. Anyway, rate conversion problems tend to throw people for a loop. And one classic one is converting kilometers per hour over to meters per second. So the first thing to understand is that when I say rate, a rate is something that is changing with time. Or something measured versus time, all right? So really what we're talking about here is a speed or a velocity, and that's how much distance you're covering in a given amount of time, right? Your pay rate is how much money you get paid in a given amount of time, and so on. Rate conversions can be a bit of an issue. So let's imagine that you have a speed of 100 kilometers per hour, and you want to know, if I go 100 kilometers every hour, how many meters am I covering every second? Okay, so you cannot just do a direct conversion because you have to convert both the distance part and the time part. Okay, and the distance part's fairly straightforward because it's metric and you just go by tens, but time is, we'll say, a little more difficult to deal with because when you get into hours and so on, you're dealing with 60s rather than tens. Okay, when you go smaller for seconds, that's fully metric, but minutes and so on are not metric and they're in common use, so we have to talk about them. All right, so when you get a problem like this, basically what we're going to do is we're going to look at the distance part separately from the time part. Okay, so we're going to ignore time for now. We're just going to focus on this part right here. Okay, so the first thing we're going to do is realize that there are 1,000 meters in every kilometer. Okay, so there's our conversion factor. We're just going to go ahead and do that right off the bat. 1,000 meters happen every time we go through a kilometer. So if I multiply this through, I'm going to get 1 times 10 to the 345. Okay, kilometers cross off, so that's meters every hour. I'm going 100,000 meters every hour. 100 kilometers is the same as 100,000 meters. It's happening every hour. So 1 times 10 to the 5 meters every hour. Okay, so one objection to using scientific notation, if it's causing confusion, it's exactly like saying this. 100, right, 1,000 meters per hour. These are equivalent units, all right? I would suggest getting used to seeing it like this. Okay, the more you see it, probably the more sense it makes, but since our main goal isn't really dealing with this type of notation, yeah, I'll also write it like this just to help make it more clear. Okay, so 100, okay, kilometers, there's 1,000 meters in every kilometer, so we got to have 100,000 meters happening every hour. Okay, so the second part now, we got to knock off hours, we got to change hours to seconds. Now we're going to deal with the time factor here. So we know that in every minute there's 60 seconds, and in every hour there's 60 minutes. So we would just simply say this: 1 hour times 60 minutes every hour times 60 seconds every minute. Oh, I'm running out of space, -1. But basically hours cross off, minutes cross off, and we're left with seconds. And we should have that there is 3,600 seconds happening for every 1 hour. Okay? So we're going to go from hours to seconds. Okay? So if we have a look here, I'm just going to take this value, 100,000 meters per hour, and I'm just going to multiply by our conversion factor. Well, we see a problem here, don't we? And let's just think about this. If I go 100,000 meters in an hour, I must go much less than that in 1 second, right? If I go 100,000 meters in 1 hour, I'm driving my car, every second I'm only covering a small fraction of that, right? So this is the thinking. So the answer we should get in terms of meters is much smaller than this, okay? And if we look, the hours are telling us this. If we just multiplied this through, we would not convert from hours to seconds. We get hours to the -2, which really doesn't make sense. So what we need to do is we need to divide by this value or multiply by the inverse. When we invert, we change our signs over. Okay, so that's now to the -1 seconds, right? And to the +1 hours. Or we're saying that a second is equal to 1/3600th of an hour. All right? We're going to go through and do that math. Okay, we're going to divide that out. Divide that out and you get 27.7, okay, with some change on there. And we do our crossing out, right? Hours go away now. Our units that remain behind are meters per second. And that's what we were looking for all along. Now this type of problem often leaves people feeling like quite challenged. But once you get a handle on this system of dealing with your units, it becomes very difficult to make a mistake on this, especially if you're thinking each step through, like should this value come out smaller or larger, right? Because there's always checks and balances along the way. It's not like you just have to like pull this out of your ear right off the bat. You kind of follow through with this method and you'll end up with a result that really, it can't be wrong, right? As long as you follow these steps through carefully. So I'm going to give you guys one to try here. What happens if you are going, 45 meters per second? And I want to know, what is that in terms of kilometers per hour? Okay, I'll give you a hint. The same conversion factors will apply, except you're going to use them in a different way. Okay, so I'm going to pause for a second, give you a chance to try this. Okay, so if you want kind of a stepwise way to think about this, step one, choose which of these we're going to deal with first. Okay, in my opinion, okay, it probably makes the most sense to make your number bigger first and then make it smaller. So what I mean by that is, think about it. If I'm going 45 meters every second, right? There's 1 second. After 2 seconds, I've gone 90 meters. Okay, after 4 seconds, I've gone 180 meters and so on. In other words, after an hour, after 3,600 seconds, I've gone a whole lot of meters, right? Does that make sense mentally? You wrap your brain around that concept? Now let's see what that looks like. So pick a unit. Honestly though, it doesn't matter if you choose these to deal with first or these to deal with. If you change your meters to kilometers, you're just going to have like a really small value and then bring it back up with the time. Pick a unit, it doesn't matter. I choose to pick time first. So what we're going to say is there's 45 meters every second. That's going to happen 3,600 times in an hour. Okay, that's right. I should get a larger number. My seconds will cancel off when I write it like this. And I get, so you will get why did that change color? 62000, or 1.62 times 10 to the 5 seconds. No, not seconds. All right, meters per hour. Okay, so 1.62 times 10 to the 5 meters per hour. Your next step, okay, so you picked a unit, you dealt with that unit, deal with second unit. So in this case, the second unit you have to deal with is taking meters over to kilometers. So 1.62 times 10 to the 5 meters, happening every hour, times 1,000 meters in every kilometer. All right, but we're going to end up with a smaller value here, right? So we actually have to do our inverting here. We have to change our signs. That one we can just get rid of. Okay, and really the nice thing about scientific notation here is if we're dividing by 1,000, we just drop this number 3 times. or 62 kilometers per hour. The key thing when you're doing this is do not like ignore your units. Bringing your units along is extremely important. No matter how well you understand this, it's always great to have this secondary check of bringing your units along, right? If all of a sudden you end up with units that don't make sense, or you're butting, two negative ones up against each other when you shouldn't be, that's your clue or your key or your secondary way of understanding, hey, something I did somewhere along here isn't right, okay? Now you're going to get all kinds of crazy conversions. You're going to get, inches to meters. You might get light years to, kilometers, and so on. But this method works for everything, okay? Let's try one more just to challenge us, okay? So I'm going to leave you here with the last little challenge problem, and this is a gas price, very classic example. In Canada, right now, if we go outside, I think gas prices are 98 cents a liter. That's probably 98.9 or something per liter. If I go down to the States, I might find that we have gas for $2.10 per gallon. Okay. The thing is, this is Canadian and this is US dollars. So if I give you a couple of conversion factors, you should be able to take this value and put it in terms of Canadian units. Okay, so that's the challenge for you here. Can you do that? So the first thing is, I believe last time I looked, 0.7575 US dollars equals 1 Canadian dollar. Okay, and there are 3.78 liters in 1 gallon. Okay. So with that information, you should be able to take this gas price, which was a gas price I looked up the other day for Minneapolis, all right? And you should be able to work that out and convert that into Canadian thinking. How many Canadian dollars is that per liter? Okay, so the goal here is to compare similar things that are measured in different units. Just a little aside here. Physical properties are not the same as the units used to measure them, okay? Not equal to their units. So this right here, right? This is a length. That's a physical property. I could measure this in many different units. I could measure it in cubits. I can measure it in feet. I can measure it in inches. Or I can measure it in meters. I can measure it in centimeters. Okay, you're going to get a different number for each one, all right? But the physical property is the same, all right? So the physical property we're measuring here is liters and gallons. So those are volume measurements. There's lots of ways to measure volume, right? Liters, gallons, those are the two that we have. There's pints, there's cups, there's cubic decimeters. Really, there's a ton of different ones, okay? So the physical property, all of these measures volume, okay? Worth is another, I guess, sort of a physical property, and we're measuring it in either Canadian dollars or US dollars. So if we want to go from one unit to the other, we need to know conversion factors. We know this is at 12. We go from meters to centimeters. We know this is 100, right? So that's the thinking. If we want to compare two things, we have to be in the same units or it's difficult to compare. Which is a better deal for gas? A gallon is bigger than a liter, but US dollars are worth more. So what do we do? So what we're going to do is we're going to take the US value and convert it into Canadian measurement is what we're going to do. So we'll start with the money. Okay, so if you remember from our steps before, we're going to start with the money. How much is $2.02 cost us as Canadians in Canadian dollars? So $2.10 US per gallon. Okay, well here's our conversion factor times 0.75 US for every Canadian dollar, right? So for every Canadian dollar you give to the bank, they'll give you back 75 cents US. It's worth less money, all right? So in other words, we would expect that an amount in US dollars will cost more in Canadian money, right? A pair of shoes that cost $100 US costs more in Canadian money when you go online shopping or whatever. It's going to cost you more. Costs you more, well, we got to divide by the decimal to get a higher amount. What we have to do is we have to invert our signs, just like we've been doing. What that will do, take 210 and divide it by 0.75, we'll simply convert the US value into Canadian dollars. So that gives us 280 Canadian per gallon. Okay, so now we're going to take that, 280 Canadian, we've converted the dollar amount over to our units of measure. Okay, and we know that there's 3.78 liters per gallon. Okay, so a gallon is larger than a liter, right? There's almost 4 liters in a gallon. So again, we expect a smaller value here. And if we look, our units remind us that yes, we have to switch this over. Invert that and invert that. Gallons cross off. We should be left in money, Canadian money, per liter. And I get 0.74, actually 741. So what we're saying here is, if I drive down to Minneapolis right now, in Canadian dollars, I'm spending 74 cents Canadian per liter, right? So Canadian per liter. There's our units that are left over, Canadian per liter. Compared to here, where it's about 98 cents Canadian per liter. So we've taken this US value and we've converted it to units that we can understand so we can make a direct comparison between the two. Without the converting, you know, we can't do that. I mean, most people can't do that in their head. It's tough. So this is why we have this system for dealing with scenarios like that.